So last time when I messaged in the WhatsApp that is there any confusion on any topic or not. So one or two of you have mentioned one or two topics. So I thought that I can take some time to discuss them. So it would have been better that if you could have managed a time to discuss this in a Google Meet. But I think that in that case some of you may not join due to other exams also. So that's why I'm preparing a video that is also in the mobile, not in a laptop. So so that you can see it in your convenient time. This is basically the vibration transmission and isolation. Though I have written the vibration isolation, but the same expression is there for transmission also, and I shall gradually explain what is there. So here you can see that a spring mass damper system is there, and it is excited by a forcing function f0 sine omega t, or I can write it in the f bar e to the power I omega t, means either in the harmonic form or in the exponential form. We can express both the things are having the same meaning. Okay, now the force which is there that can be transmitted, or that has to be transmitted via the spring and the dashpot which is attached here. Okay, now Fs is the force which is getting transmitted by the spring, and Fd is the force which is getting transmitted by the dashpot. Now apart from these two things, there is no other thing attached to it, means whatever is there in the body, or suppose the mass which is getting excited by external force, that force is getting transmitted via this two medium only. Okay, so if I want to isolate this vibration, if I don't want that this vibration should not reach to the ground even though it is vibrating, then means I am isolating them. Okay, and another thing is, if I am transmitting this force, means whatever is getting excited on this mass, that force is getting transmitted to the base which is attached with it. Okay, so these are the two things. Means in one case the requirement will be to keep it safe from the vibration, or keep the base should not excite in that way, or in other case, if something is vibrating, how much amount of force is getting transmitted to the other device which is attached to it, that is the transmission. In that case, another case is isolation, but in both the case the expression will be same. Okay, you can check it in the book also. Here what I have written, the force transmitted to the base is via the spring and damper only. I shall share you the PDF also. Now you see we are drawing the phasor diagram. Phasor diagram, you know that in the one axis it will be real axis, and in another axis it is imaginary axis, because you see e to the power I omega t, that we can write in cos omega t plus I sin omega t. Okay, so these expressions can be written in the summation of combination of real and imaginary terms. That's why we can express them in the phasor diagram also. Okay, now in the phasor diagram what we can see, that suppose initially that will be the spring force, and I have assumed that x is the amplitude of the displacement, which is the solution we have assumed. Okay, suppose x we have assumed as capital X sine omega t, or capital X e to the power I omega t. Okay, depending on the forcing function nature, we shall decide that what sort of solution we need to assume. Now based on that, the amplitude or the magnitude of the force, spring force, will be given to us, that will be K capital X. So Fx is K capital X. So in the phasor diagram, suppose this angle which I have not shown, maybe a theta or phi, whatever you can consider. So that will be a certain angle, and I shall give it in a arrow like this. Now as we know that the damping force will have a phase difference of 90 degree with the displacement. Okay, because that is the velocity term. Okay, so accordingly we have done this FD omega cx FD, and we know that the inertia force will be with a phase difference of 180 degree to the displacement. So it is m omega square x, and we already know that how to draw these phasor diagrams. The closing side will be the amplitude of the exciting force, because all these forces are due to this exciting force only. This inertia force, the spring force, the dashpot force or damping force is coming into picture. So the closing side, or the summation, you can say the closing side will be f0. Okay, that is fine. Sorry. Now the transmitted force, transmitted, in this case we are considering is transmitted. Later on we shall show that what is the basic term difference between the transmission and isolation only. Now transmitted force which is getting transmitted by the spring and dashpot only, that is the summation of Fs and Fd. So this Ft which is in the dotted line, Ft will be the summation of these two forces which are getting transmitted. So we can definitely find it out, Ft equal to the root under F square plus Fd square. Okay. Now transmitted force that we have written here also, that is if I write the expressions, then it is x we shall take out of the root and it is k square plus c omega square. Now transmissibility ratio. What is the transmissibility ratio? That is the what is the amount of force which has been transmitted to the amount of to the exciting force. So in this case it is Ft by F0. That is the transmissibility ratio. Okay. So transmissibility ratio which you can represent as TR. So it is, this one we have already found out, and this one is nothing but, we know that that will be the summation of, if I draw a let me draw it. If I draw a line from here to here, okay, so this side will be the kx minus m omega square x, and this side will be omega cx. Okay, so then in that case f0 will be root under kx minus m omega square x whole square plus omega cx whole square. So that is what we have written here, this one. Okay, so that is the expression. So x is getting cancelled, so transmissibility ratio is k square plus c omega square whole square, k minus m omega square whole square plus c omega square. So if we know it very easily that if we make them non-dimensionalized, that is the term which is coming. Okay, k ko bahar le aaye, so all the terms will come and we know it very easily. Okay, that is the transmissibility ratio. In case of problems, actually you need to remember this transmissibility ratio expression only. Be it a transmission or isolation, you need to remember this expression only. Okay, certainly I shall tell you that what are the points we need to cover, but for the timing you can remember, or this is not a very complex relation, so you can definitely remember transmissibility or isolation. Now coming into the graph. Okay, now you see this graph has started from here. So what we can get it from here, this is the transmissibility ratio in the y-axis and r is in the x-axis. Okay, so if suppose zeta is not there, if there is, this is true for all the values of zeta including zeta equal to 0. Okay, if zeta is not there and r equal to 0, you see tr equal to 1, because r will be 0, zeta is 0, zeta is 0 here. If r equal to 0, then transmissibility ratio is coming as 1. So at r equal to 0, this is the 1. So from this point all the graphs are starting. Okay, and it will gradually increase and at any maximum value for undamped one it will be infinite. Definitely if r equal to 1, you can see this maximum amplitude will happen at r equal to 1. Okay, please don't mix it with the force magnification factor. In case of force magnification factor, force vibration पे, in that case maximum amplitude has taken place slightly ahead of r equal to 1 due to presence of damping. That was the amplification. Okay, that is the x by f0 by k. That was the expression. But in this case, this is happening at exactly at r equal to 1, because see, if there is no damping, zeta equal to 0, at r equal to 1, this is infinite. Okay, gradually for other values of zeta, the graph will look like this, and you will find out that all these points are crossing through a particular point which is r equal to root 2, and that is, we know that the zeta insensitive point, because all the zeta, for all the zeta values, they are crossing the same point. Okay, now you see here, beyond r equal to root 2 means within r equal to root 2, the transmissibility ratio is always greater than 1. In every case it is greater than 1. मतलब force जितना इसको vibrate करा रहा है, how much amount of force is getting here you see the displacement what is taking place due to this exciting force here. The displacement which is getting transmitted is force which is getting transmitted is more than that. Okay, I'm again telling the point. The exciting force and the transmitted force within r equal to root 2 is greater than the exciting force. That's why tr is greater than 1. That means ft by f0 is greater than 1 when r is 0 to root 2. But when it is crossing the root 2, you see that the r is less than 1. ये ग्राफ नीचे की ओर आ रहा है, r is less than 1. मीन्स यहाँ पे जितना फोर्स जाना चाहिए था उससे कम जा रहा है बेस पे. मीन्स एक्साइटिंग फोर्स इज समथिंग बट द transmitted force is less than that. And in case of isolation I want that only, that ये बॉडी जितने भी एक्साइटिंग फोर्स की वजह से वाइब्रेट करे, आई वांट दैट लेस अमाउंट ऑफ फोर्स शुड गो टू द basement or see wherever it is attached. Okay, so this zone is the vibration transmission zone. Vibration transmission, क्योंकि यहाँ से force transmit हो रहा है and with a ratio of tr greater than 1. But beyond this r equal to root 2, it is vibration isolation because जितना force actually excite कर रहा था उससे कम force base पे पहुँच रहा है. Okay, means in that point or beyond that speed ratio, the vibration is not getting transmitted or less amount of vibration is getting transmitted. इससे आगे भी जाएंगे तो देखेंगे ये ग्राफ नीचे की ओर आ रहा है. This will gradually come reducing. Okay, means at higher speeds you see that the exciting force, higher speed means what? R equal to और भी ज़्यादा वैल्यू क्या मीन करता है? Means it is R equal to nothing but omega by omega n. ये omega क्या है? Omega is the forcing function frequency and omega n is root under k by m. ये तो natural frequency है and this is the forcing function frequency. तो forcing function frequency अगर बढ़ता रहे, in that case also this r value will increase and that will denote that it is gradually getting isolated. So that's why this zone I have shown vibration isolation and this is the vibration transmission. Okay, you see here at the end I have written the transmitted force is less than the exciting force beyond the frequency range r equal to root 2. Okay, now that is clearly understood and this expression is true for vibration transmission and isolation also because the same thing is happening here. Now one more thing, आप बोलेंगे सर r equal to root 2 आपने कैसे लाया? Okay, I am telling you at this point it was 1, that is fine. Now I want to know that where are the other points because all these points are passing through this r equal to 0 पे जो 1 वैल्यू था ये सेम पॉइंट से पास कर रहा है सारे ग्राफ. So what is the other point? Where is the other point where all the graphs are passing? So that will be, if I draw a line, that will be, you see transmissivity ratio फिर से जहाँ पे 1 होगा, where the transmissivity ratio will be 1, there we shall get the second point. Okay, but the transmissivity ratio will be 1 again. So it is 1 at r equal to 0. So if I consider transmissivity ratio in this expression, if I consider transmissivity ratio equal to 1 and zeta equal to 0, I am getting a 1 by 1 minus r square. Root चला जाएगा 1 by 1 minus r square. Okay, now if I simplify it, I have not done this one. So if I simplify 1 equal to 1 by 1 minus r square. So if I am simplifying, it is 1 minus 2 r square. 1 minus r square हो जा रहा है. Just a minute. Okay, let me see. If transmissivity ratio is 1, then if I am squaring both the sides, I am having a 1 minus 2r square plus r to the power 4 equal to 1. So I am getting as r square minus 2r square equal to 0. Okay, so, r to the power 4 minus 2r square equal to 0. So r square I am taking common. R square will be taken common. R square into r square minus 2 equal to 0. So that will give us two values of r equal to 0 and r equal to root 2. So where transmissivity ratio will be 1. So that is true. At r equal to 0 it is 1, and another point will be r equal to root 2. That we have done in our classes also. Now another conclusion which can be drawn from here, that is, you see the transmission, say it a transmission or isolation, here the vibrations are happening, uh, vibration, all these forces, transmission or isolation is uh, happening due to these factors. You see the factors which are responsible here is the frequency ratio, the damping ratio, all these things. So these are responsible for the amplitudes which are rising here and taking the transmissivity ratio much higher than 1. You see, and how these damping ratios are, damping ratio is controlled by this C by Cc. Cc I can say that twice m omega n, but C is the damping dashport, damping coefficient here. Similarly, omega n or R equal to omega by omega n. Omega n is dependent on the spring stiffness value and the mass value. Okay, so I can say that the damping or the vibrational behavior or the response of the system, or the vibration transmission or force transmission or force isolations are dependent on the parameters or the elements which are attached to this mass, okay, which were attached to this body for keeping it isolated. तो इसका एक अलग सा मतलब आता है कि जो whatever thing I have attached to it to keep it isolated from the vibration, that is actually somewhere responsible for vibration, that is also responsible for its vibration. ये इसके रेस्पॉन्स पे यही चीज़ें काम आ रहा है. Obviously at higher frequency I can say that it is gradually isolating, but it is also responsible. Okay, so that's what I want to discuss. I have talked so many things, but the actual thing is very simple, and that is the ratio. Okay, that is the ratio. Take it a vibration isolation or vibration transmission, the same thing, and that can be understood from this graph only. Okay, if you still have any doubt, you can definitely write it down in the group, no issues. Okay, not necessary I shall post it today, but your exam is on a defined date, that day you can ask. Okay, for now you don't have to worry about it.